Hello my dear students, myself Dr. Upama Das, and today I will be discussing about DC motor. First, let us focus on the word motor. Why we need motor? We can see the application of motor everywhere in our day-to-day life. Starting from the grinder mixer or maybe the water pump, the very basic application like ceiling fan, stand fan, and of course washing machine. There are so many examples where we are using motor. Okay, it is having so many of applications. Now, what is DC motor? Why we are saying DC motor? So, is there any AC motor? Yes, definitely. There are DC motor and AC motor as well. So, first of all, why we use motor? Motor we are using to get some rotational speed. For an example, if you consider the ceiling fan, inside the fan we are having one motor, and here I want to mention that this is an AC motor. Now, after giving the supply, when switching on the fan, this fan is rotating. What we are able to see? We are able to see that the fan blades are rotating. Actually, these blades are connected with the shaft of the motor. As the motor rotating, with that connected, these blades are also moving. And of course, it's cooling down the temperature of the room. So if we say properly, then we can comment that motor is a device which takes electrical energy and convert it into equivalent mechanical energy. Now when we are saying DC motor, it means we are giving DC supply to this motor. The electrical energy in this case is DC, means direct current. Now let's see the working principle of DC motor. Whenever any current carrying conductor is placed inside a magnetic field, due to the contradiction between the magnetic field and the electric field, one force exerts on it. This force name is Lorentz force. Due to this force, one torque generated, and this torque leads to the motor to rotate. Here you can see in the construction we are having some field winding and we are having some armature conductors. Let us focus first on these two. What is field winding? See, this is the field coil. Whenever we are saying winding means some coil sort of thing is there. So you can see here the field coils, and it is also called stator. So there inside the motor we are having a magnetic field. In the principle already I mentioned magnetic field. The field coil is providing this magnetic field. Okay, only if you are having the field coil can it provide the magnetic field? No. So we have to give supply to this coil so that it will get energized and work like an electromagnet, and it will create the magnetic field. And here, as you can see, the name stator, this magnetic field or this field windings are static. They can't move. We have fixed them with the surface or with the setup of the motor. Inside these are fixed. They can't move. The rotating part is the armature. The rotating part is the armature. The rotating part means which is rotating. Now which part is rotating? The current carrying conductor is rotating. Whenever any current carrying conductor is placed inside a magnetic field, it will feel a force, and due to this force one torque will generate and this conductor will start to rotate. Now any bare conductor, you can't keep it like this because it's rotating. It will rotate. So you have to place those conductor in a systematic manner to somewhere. This somewhere is called armature. Armature is a cylindrical drum sort of thing where some laminations we used to put. That's the other reason of this one. But there are some slots present, and inside this slot we used to place the current carrying conductors. Okay. In general, first we used to place the conductor, and then after we used to give DC supply to this conductor, and that's why the name DC motor. So this armature means this conductor assembly, it's rotating. Okay, it can rotate, that's why the name rotor. And what is the stator? The magnetic field is the stator. Remember, whenever two magnets are placed together, two things can happen. Either they will get attracted or they may feel some repulsive force over there. Both the condition, they will move from their place. Now, if one magnet is fixed, then another magnet, depending on the attraction or repulsion, it will come closer or far from the other magnet. The same thing we are using here in the case of DC motor or any motor. So here this field winding is energized, and then magnetic field creates, and in the armature conductors we are giving the supply. So current carrying conductor also we got, and the magnetic field is also created. So now this rotor or the armature will start to rotate. This is the basic operation. But here 2-3 more parts are important, like when you will be giving supply to the rotor section, the supply will go via commutator and brush assembly. The job of the commutator is to provide this electrical supply to the armature. Now, when you are giving the supply is given via the brushes. Mainly these brushes are made of graphite, carbon or graphite, and steel brushes were also used, but these brushes are placed over the rotor section, and this rotor is rotating, so some sparks used to generate, and that's why some brush contact drop is also occurs. So in case of carbon brush, this drop amount is very less. That's why we prefer carbon over any other materials. Okay. So up to here, I think it's clear what is the basic principle of motor. Why it is called DC motor? This is the reason, is the supply which we are giving to it. Next, the different parts, the main parts actually we have discussed and their purpose. In the upcoming lectures, we'll be discussing about different types, and before that, little bit more idea I'll be giving you how motor operates. Hopefully, this video gives you some knowledge about the motor and you'll be interested on this topic. Thank you. See you soon.